So in section 4, we're going to start introducing inequalities so we can talk about systems of inequalities. So when we talk about a linear inequality, it's two or more expressions or values compared by inequality symbols. So just review our 4 inequality symbols. The first one we have there is greater than. The next one is greater than or equal to. Then we have less than and less than or equal to. When we are modeling with a linear inequality, what we're trying to do is determine the maximum or minimum value of a situation. So a few examples of this are profit, speed, time. There's plenty of examples that we have that can be modeled using an inequality. So in our first example, we have that a raffle is being held for a fundraiser. Tickets for the raffle sell for $2 and the club spent $20 to put together the baskets. How many tickets do they need to sell in order to make more than $200? So one half of our inequality, so one side, is going to be a linear equation. Then you'll have an inequality instead of an equal sign, and then the value. So for our linear equation side, I'm going to have T be my number of tickets. So when we're talking about making money, so they're going to make $2 per ticket they sell, so 2T, but they spent $20 putting together baskets for the fundraiser. So you actually need to subtract that from the 2T because it is taking out of potential profit. And you want to make more than $200, so we'll have a greater than 200. So that is the inequality that represents this scenario. So now I just solve for T. So we're going to add 20 to both sides. So we'll have 2T is greater than 220, divide by T, and we get that T has to be greater than 110. So they need to sell more than 110 tickets. For our second example, we have that Miss Huffman is planning a math day party and cannot spend more than $300. She spent $25 on pop and wants to buy as many $10 pizzas as possible. How many pizzas can I buy? So for our equation side, we'll let P be our number of pizzas. So it's going to be $10 a pizza, so 10P. And I've already spent $25 on pop, so that's going to be plus 25. Because this time my equation side is representing the amount of money I've already spent. And that has to be less than or equal to 300, because I can't spend over $300. I can spend exactly that since I have that amount of money, so I can have the equal to. So now we're going to subtract 25 from both sides. We get 10P is less than or equal to 275. Then we'll divide by 10, and P has to be less than or equal to 27.5. So I can't buy a half a pizza. I can only buy whole pizzas. So that tells me that Miss Huffman can buy at most 27 pizzas. All right. In our next example, we have that Elizabeth currently has 12 Instagram followers. She gets 4 new followers every day. How long until she will have at least 100 followers? So I'm going to have D equal our number of days. So 4 followers per day, so 4D plus 12. And if I want at least, that's going to be greater than or equal to. So we'll subtract 12. So we get 4D has to be greater than or equal to 88. Divide by 4, and D has to be greater than or 22. So it will take Elizabeth at least 22 days. Okay. Number 4, DAC students are going on a field trip with 195 students and 13 adults. Each bus can hold at most 40 students. What is the minimum number of buses needed? So for our inequality, B is going to be our number of buses. So when it comes to our inequality, we can fit 40 students on a bus, so 40B. And then we have to be greater than or equal to, because if it's a minimum number, the inequality is always going to be greater than or equal to. Now, we have 195 students, but we also have 13 adults. So our total number, I have to do 195 plus 13. So that's 208. Then we'll divide by 40. So B has to be greater than or equal to 5.2, which means DACC needs at least 6 buses. Because the next whole number that is greater than or equal to 5.2 is 6. For our last example, we're going to look at 2 different things. So we have that a 2,500 seat stadium is being filled at a rate of 10 seats per minute. Of the seats, 350 are reserved for special guests. So A asks us, after how many minutes will all of the seats be taken? So our variable M is going to be our number of minutes. So our rate is 10 seats per minute, so that's 10M. Now, some of our seats are already taken, they're reserved. So 350 of the seats are already taken, so plus 350 has to be less than or equal to our total number of seats we have available, 2,500. So we'll subtract 350 from both sides. We have 10M is then less than or equal to 2,150. Divide by 10, and M has to be less than or equal to 215. So that tells us it will take at most 215 minutes to fill the seats. Now we're going to take a look, same situation, but now money associated with it. So to cover costs, organizers must raise at least $39,000 from ticket sales. They sell tickets at $25 each. How many tickets must they sell? So T is going to represent our number of tickets. So when we set this up, it's $25 a ticket, so 25T has to be greater than or equal to 39,000. So we'll divide both sides by 25, and T is greater than or equal to 1560. So that tells us organizers must sell at least 1,560 tickets. Please let me know if you have any questions about setting up an inequality, linear inequality, and how to solve for a variable.